Welcome to Industry Insights with AIM Solder, a video and podcast series where we dive deep into the world of soldering and electronics assembly with the industry's top minds. I'm your host, Gail Towle.
I'm Gail Towle, your host, and today I'm thrilled to speak with none other than Chrys Shea. Chrys is the founder of Shea Engineering Services and a recognized expert in soldering process optimization. She has decades of experience in electronics manufacturing and contributed extensively to industry research. I believe has hundreds of papers published at this point. A lot of work with stencil printing, solder paste evaluation, numerous prestigious SMTA Member of Distinction Award and the winner of the International Best of Conference Award, probably a bunch of other things. I don't know if you have anything to add.
Yeah,
the bulk of it.
Yeah.
Basically, yeah.
I've been around 35 years, so
yeah,
there's something that keeps me in the business. Yeah.
You know everything now. So because you know everything, we want to extract some of that and share it with the wide world. Especially all those young people who are like, what am I going to do when I grow up? And like electronics manufacturing, right? Who wouldn't want to work in this field?
It never gets old.
Exactly.
It's always something new and exciting.
We were just talking before we started recording about how cool it is and how much we love just learning the science and figuring everything out and seeing what comes next. And not only do we get to apply all of our scientific and analytical skills, but it's to something that you actually make and turns into a product and people use it. And that's pretty cool.
Yes. So what's really cool is when people show you their new gadget and you're like, yeah, I prototyped that about 18 months ago.
Yeah, I'm like,
not new to me.
Our solder is in that thing over there. Yeah, our solder is out in outer space right now, and our solder is like in a bunch of different countries, and it's very cool.
Yep. So, people go, what do you build? I'm like, I've been doing it 35 years. I've had a hand in pretty much every step of miniaturization. So, yeah, what happened? I somehow got my hands on or influenced somewhere.
Yeah. I mean, it's always changing. There's always something new to try to like improve on and make a better alloy, make a better process. Like, yeah. So you're just solving
make it smaller,
problems,
lighter, faster. Yep.
Playing with cooler toys and hanging out with cool people. What's not to love, really? So yeah. So this is the first of a 3-episode series we're gonna do with you. And we're sort of going to focus this first one on your journey from engineer to industry icon, because of course, everyone probably knows who you are. And if you don't know who Chrys is, then, you'll watch this video and you'll know. So that's about to happen. So you've had a lot of roles, Motorola, Siemens, Speedline. How did you get into electronics manufacturing in the first place? What are the origins of Chrys Shea?
I wanted to build cars from the time I was like 4 or 5 years old. I went to school for mechanical engineering. I got a fellowship from Ford to go to grad school for manufacturing engineering. I went out and worked for Ford for a year and was completely disillusioned. At those shops, engineers' hands are tied. We can't touch anything. I found out that it was really cool building an assembly line, but that line is going to last for 8 to 12 years, and it's going to do the same thing over and over again. It's hard automation. Yeah, you got to get it just right, but it's still, once it's done, it's done. So I heard through my graduate school that Compact Computer was looking for people in Houston for their DFM efforts. So I went down there and interviewed, and the Fuji CP2. All right, we're up at like CP7 now. The CP2 was this placer that had this giant trolley that ran back and forth with parts on it. And it could place parts plus or minus 0.005 of an inch, and it could do 25,000 parts per hour. And you could program it to do whatever you wanted. And I was like, oh, this is so cool. This is the automation I want to work on. Sign me up. So that's how I got into it. And then I did that. I did a lot of new product work, and I did tab bonding, like back in the early 90s. So a lot of fine pitch placement. And then I found myself at soldering, and that was my home because I always liked metallurgy and material science, but I realized when I took a graduate level class in that it wasn't my thing. I'm good down to the molecule, and once you get inside the molecule, my brain doesn't like do so good anymore. So I'm better off with encoders and servos and things like that. But now with soldering, first I was in wave soldering, and for me to be able to take a 2,000-pound vat of molten metal and make it dance and go where I wanted it to go and not go where I didn't want it to go was pretty cool. Then, I graduated
fluid dynamics.
Yes. Which, guess what? Solder paste is this non-Newtonian thixotropic fluid. So how could I not be drawn to that?
Yeah.
That's how I got printing, reflowing, mass soldering of all types. It's fun.
Exactly. Like that's the one thing, like my background was math and physics, and coming into the land of solder, I still remember being interviewed for my job and them trying to be like, it's just like gray, mushy stuff. It's not that exciting. And I'm like, what do you mean? Like I can find so many things about this that's just interesting. Like, yeah, and it just keeps going. There's always something new to learn. There's always something new to figure out. And it is everything. Like, I mean, I studied like quantum mechanics and stuff down to that level. So we're not quite hitting in that space so much, but like everything I ever learned about, fluid dynamics, phase changes, thermodynamics, capillary action, the chemistry involved. Like it just goes on and on and on and on. And it's neat.
It's really neat. It's really neat. I've tried to retire once or twice and I can't. It's just so much fun. It's just so much fun.
Yeah. So that'll bring us to our next question. So what pushed you to start Shea Engineering? Which is what you're doing now, and how did that transition? What inspired the transition, and how's that been going? And what are you up to these days?
Well, I started it 17 years ago, and I'm much better at data than I am at politics, company politics. So I decided if I could control company politics, it would be my company, and all I have to do is walk the dogs before my first conference call. And my office is peaceful and there's no drama. So I'm a lot more drawn to data than anything else. So my husband had been bugging me to start consulting for years. And I was like, when I finally decided to strike out on my own, it was not to consult in this business. It was actually to do more technical writing and explaining things to, let's say, women of my demographic who were raised without technology. And people heard I was leaving that job and they just kept calling me. So it just sort of grew organically over the last 17 years. And here I am.
Awesome. So of note is the fact that you're somewhat of a minority in the field, right? There aren't very many redheads. Yeah.
No, not at all. Especially ones that are pushing 6 feet tall.
Have you found that to be ever an issue or a hindrance, or, so in the male dominated realm of electronics manufacturing, has it ever been weird being the only woman in the room, and anything you ever encountered with that?
It's rare when I'm not the only woman in the room. We're starting to see a little bit more parity now, but I think one of the more challenging factors, and that goes back to company politics, is the out of office activities, the rugby matches, the golf games, the gym memberships, the other gentleman things that gentlemen did a lot before people started cracking down on expense accounts that would exclude women from the process. And a lot of that, you get a lot of side conversations. It's interesting because I witnessed it with my husband's growth through management. So many of these decisions are made at the pub, on the golf course, on weekend hunting trips. And club is really hard to break into. Let's put it that way.
So we need to encourage more of a culture of like co-ed softball, something of that nature, right?
Bowling.
Exactly.
But rugby, no.
Yeah, see, that's the trick. I know that like I go, a lot of times when I'll see my coworkers and it's like everyone's talking about a football game and I'm like, "Ugh, what's going on with that?" But you guys sound really happy and excited. So good. But yeah,
Exactly.
so things like that can be a little alienating. But some women are into football too, so then they do fine in that space. And
I know a lot of them who started joining fantasy football leagues and taking golf lessons and doing all that to try to break into that club.
Mm-hmm.
Yeah,
it can be a little weird. I've always felt like most of the things I found interesting in life that I start, looking at or studying and wandering into this space, it's like I just wander in because I'm fascinated, and then I look around and it's like, where'd all the women go? Well, but yeah, it's I mean, it's hard to say how much of it is just like general in tendencies towards different interests versus like how much of it is cultural, or you just feel the slight nudges of alienation and you move somewhere else. And
yeah, I don't think it's intentional.
No,
but
I mean there may have been a
there.
time when it was intentional.
Oh yes.
I don't.
Oh yes.
I don't get that. I don't get that vibe these days so much.
No, it's not intentionally exclusionary. It's just by default exclusionary.
Mm-hmm.
And maybe that will change as we see more of the retirees retiring and the younger people taking over, people who grew up with moms who worked, with wives who work, who help balance the whole family work load. I think we'll probably see some movement in the right direction. But establishments are establishments. They're well established.
That's true. And they're like, it's like a big, massive thing with momentum. So it's hard to start nudging it down a different path.
Yes. And if somebody gets into that club, are they going to turn around and reach to bring somebody else in? No, they're just going to be happy they got in that club.
Like, I made it.
Yeah. They're not going to make any waves. They're going to be like, I got the
club. Yeah.
That'll have to change when we go more on merit than relationships.
Mm-hmm.
I think that will change. It's just not changing fast enough for me.
Time to start going on the speaker circuit. Inspire the middle schoolers and the high schoolers.
Yes, because this is fun. Let's not forget.
Yeah, exactly.
The reason I do this, it is so much fun.
Exactly.
Somebody pays me good money to do something I enjoy. Why wouldn't I?
Mm-hmm.
Why wouldn't I? Now let me ask you, how do you deal with mansplaining? When you walk into a room and ask a question and people don't know that you're a physicist and mathematician and solder whiz, how do you deal with that?
You're reminding me of a time at a family reunion where I had, I just got like my master's degree in physics, and my uncle was explaining black holes to everyone and incorrectly, and I'm like right there, and I'm like, all right, well. But yeah, no, I think some of it is just a matter of the confidence you exude yourself. If you walk into a room and act like you know what you're doing and that you should be there and that you know just as much as everyone else, people will pick up on that. I definitely earlier in my younger days would have times when, I was like, your default is like, I'm the unknowing one and everyone else knows more than me, and I'm just here hoping they accept me. And I'll just talk right over you and explain things you already know. But if you walk in the room and you start saying things that are legitimate and mean stuff, then people tend to just naturally go with that. So just be a bull in the china shop, take up space, and just start saying the things like you know what you're talking about, and everyone will go along with it.
Oh, okay. See, I kind of go the other way. I when I start getting some of those like oversimplified explanations, I really tell me more.
Oh, you just play.
And then I let it go on
like,
for a while, and then I ask the tough
go?
question, and I see the. It's like, honey.
Well, so you just have fun with it instead. Yeah,
I
guess
do. I have
that's
to.
another approach.
You know, have to. You have to have fun
Mhm.
with it, but yeah, you have to get the point across.
Mhm.
So I found like if I walk in acting like I know everything, well, every time I go into a shop as a consultant, I meet with a senior engineer who thinks I don't need to be there.
Mhm.
And I get met with this body language.
Mm.
And I usually get met with that senior engineer being late to the meeting because he's too busy fixing something
Mhm.
on the floor that I wouldn't understand. And they always try to like trip you up or ask you trick
Oh yes,
questions.
yeah.
And you
So
have to
you
be like, no, there's a difference between mid chip and random solder balls. Which one are you asking me about? And then, like, oh, maybe she does know what she's talking
Yeah,
about.
exactly. So that's
Uh,
the real key is just let them walk into your trap. You didn't attack or offend or do anything. You're just curious, and we've now found the root of the problem is you don't understand what's happening here.
yeah, I just had.
We're really trying to introduce you to anyone in the industry who's not already know you, and I think we're doing a really good job. We're getting the full
Yeah, because this
spectrum.
is me. This is one
Exactly.
of the reasons I work for
Exactly.
myself. You would not want to be my boss 40 hours a week because I mix up thought bubbles and speech bubbles all the time. When it's supposed to say
Yeah.
a thought, whoop, it came out.
It just fell out. Whoopsie.
Yep.
Yeah. I feel like that happens to me a lot more. Like the older I get and the less I care about other people's opinions, it just starts falling out.
Exactly. After the age of 60, I'm like, what do I care?
So now we want to do a little show and tell.
Okay.
You are the queen of solder, as I understand it.
Yeah.
So how did you get this title?
It was given to me by an engineer that I have so much respect and admiration for. She's absolutely brilliant. We used to work together, and we're hoping we can work together again sometime. But 2 summers ago, I celebrated my 15th anniversary as an independent consultant. And I had a little party out back, and I invited all my nerdy engineer friends. My husband was like, oh boy, 35 engineers, whoop, whoop. But then he soon realized that the engineers I hang out with are pretty cool. Anyway, she brought me this giant banner that I'm trying to hold up. I don't know if you can see it all.
Yeah.
But at the very bottom,
it has your title.
The Queen of Soldering.
Beautiful.
And you can see in the background, that's my SMTA board that I designed. And over here we have like cut from one of my papers, transfer efficiency charts, box plots. And this is the coolest part, the action shot right there of the solder paste in the jar. I can just see it in my mind coming off the spatula and back into the jar. Can't you?
Oh, yes. Very nice. Very aesthetically appealing, satisfying.
Yeah. Yes. So I've known this engineer, oh gosh, 25 years. So we know each other pretty well. And she's absolutely brilliant. And she knows me well enough that she also bestowed upon me this beautiful wine glass,
chalice,
which is basically
from which to drink the blood of your enemies.
Yeah. But I just love that it's a beaker with a stem.
Yeah.
I pull it out when I'm drinking a fine wine. That's
awesome.
not a weekday glass.
And you got it, and then you know exactly how much you're drinking too, which is great.
Yeah, I know this measures like in milliliters and 50 milliliter, 25 milliliter graduations. I measure wine consumption by the bottle. So this is really
so you need a bigger one, is
fractional.
what you're saying.
Yeah.
Awesome.
You don't see a lot of open bottles in my refrigerator.
Okay.
I don't let it go bad.
Does it even make it into the glass, or does it come straight from the bottle?
Well, it depends on how thirsty I am. And for a while, we were getting these cases of splits from Naomi. So we would just grab the bottles and put a koozie on and go back and drink them like they're
it's efficient.
Flat beers.
It's efficient.
Yeah.
Exactly.
Yeah. While our house was under construction, we would walk over here so we could watch the sunset at night and bring our little splits of Chardonnay. Worked out well.
Nice. So now I want to know, what's the most ridiculous thing you've ever seen in a soldering process?
Where do I start? Let's see. Okay, the most ridiculous thing is when people heat the solder and think it's going to somehow magically adhere itself to the metal. You heat the metal and the solder follows the heat. I can drip molten solder on a copper wire all day long. I'm not going to form an intermetallic, so I'm not going to form a solder joint. So, okay, so that's probably one of the most ridiculous things I've ever seen. Another is I had to pull a guy off the shop floor one day because parts were floating up in the wave. So he would open the window and actually push down a PGA socket as it was crossing the wave. Okay, that's not good. Not good at all. I entertained a suggestion one time when I was giving a talk from somebody who thought that if they put weights on top of QFNs, it would help push the voiding out in the reflow oven.
Did it work?
I don't know, because it's going to warp your board. You might not have voids, but you're going to have a potato chip where you put a honking weight on top of a QFN and ran it above the laminate's T sub G. Like, you're asking for trouble there. And YouTube rework. You can really find some ridiculous stuff if you Google up rework on YouTube. Do you remember the red ring of death that was going on in PlayStations like back in the 2000s?
Oh, yeah.
People were reworking it themselves with their hair dryers or their industrial heat guns at home. Hey, took the red ring away. Okay. It'll be back. Let me know how long that fix lasts.
Yeah.
But yeah, some of the soldering you see on YouTube, you're like, oh my God, I don't want that. That's why I will never buy a factory refurb circuit board for my refrigerator, engine controller for my car. Yeah. We don't. Nah.
I've seen we know what rework.
Curtain. Yeah. We know how that sausage was made. We don't want that. Yeah.
Exactly.
So. Rework is the big one, though, I think.
So, final question for this episode is, and you kind of talked about this already, but was there ever a specific moment where you really hit the, wow, this is what I love to do realization?
Yes, all the time. When somebody has the light bulb go on in their head, it's like, yes, I did my job. I demonstrated that scientific principle enough that they asked a really good question about it, so it must have sunk it in. Yes, I did my job.
Awesome. Yeah, when people ask good questions, that's always exciting. Like, I used to teach, and it was like, half the time you'd have students who were, I want to pass this class and get this credit, and I'd like this grade. I don't want the knowledge and understanding. What am I going to do with that? Right? And it makes it very uninspiring and a very sad job. But anytime I get to explain or educate people in the field, it's like they want to know these things and they want to learn more and understand. And my dog has found a squeaky ball behind me because, of course, middle of recording is the time to bring the squeaky ball into the office. But yeah, when the light bulb goes off, when they're engaged, when they get it, when they understand it, that feels so good.
I know, like one time people didn't believe that boards shrink in the reflow oven. And they do. Like, we all know that boards aren't very dimensionally accurate with respect to CAD. They always shrink. And after you do the first side, so to illustrate that, we went out to the floor, we grabbed a board, just a bare board, ran it through the SPI machine and looked at the shrink or stretch score, ran it through the oven, let it cool, and it had shrunk by 0.02% or something. And they went, oh, it really does shrink. I'm going, yeah, no, I wasn't lying, And then one of the techs said, is that why the second side stencil never lines up as good as the first side stencil?
Oh, we have connected ideas.
Yes. And then another one pipes up and says, so should we reflow a board before we get the stencil cut? Yeah.
Yes.
Yes. You know how many thousands of rework operations you have just not had to do because you got the stencil scaled for the bottom side of the board. Yes. Or last night, I got a call from guys who were working on the SMTA board going, I get it. We were doing the 0 and 05s, and now I get what you mean about variation. I didn't get it till I saw the histograms, and now I'm calling you to tell you I get it. I'm like, all right. Cheers. So yeah, that's one of the best parts. And the other is when I'm going into a factory, I'm always going in with a lot of trepidation. Like, what if I can't fix this? What if this is something I've never seen before? What if they find out I'm an imposter? And then on the plane on the way back, I'm like, why? Of course you could fix it. There's only so many things that can go wrong in surface mount.
Exactly. I mean, it's all going to follow natural laws.
Yep.
So I tell my daughter about learning math. Like, the rules that you learned before still apply to all the new math. And if you just apply rules that exist, then the outcomes will be accurate.
Yeah.
Now, in the real world, there's a lot of variables.
Mm-hmm.
So that can make troubleshooting tricky, is how many variables affect different process parameters. But it's all going to obey the basic laws of physics. So cause and effect.
Yep. One of my very, very first mentors, who I appreciated so much, taught me, takes 3 things to make a solder joint: flux, heat, and solder. If you're not getting the joint you want, figure out which factor you got too much or too little of. Words to live by. So simple. What are you short on, or what are you over on? Flux, heat, or solder? And sometimes it's easier to figure it out in one order in one process and a different order in another process.
Mm-hmm.
Like if I want to make sure I'm getting enough solder on surface mount, I'll just go check the SPI. If I want to know if I'm getting enough solder in a wave or a selective wave, and I got to get the glass plate or the data logging device. So, it's always flux, heat, or solder.
Yep. I mean, those are the primary things involved. And then there's all the variables that affect those things, right?
Yeah, exactly. Well, once you figure out what you don't have the right amount of, then you got to figure out what's affecting it. But, first you got to figure out what you don't have the right amount of.
Exactly. Well, that wraps up our first episode. So we hope people tune in to the next episode. We got two more times we're going to be talking with Chrys. Thank you for today.
Thank you, Gail.
We hope you enjoyed this episode of Industry Insights with AIM Solder. Don't forget to subscribe to our channel and follow us on social media for updates and new content, or visit aimsolder.com to learn more.